experiment we shall investigate the reflection and refraction of light rays. We require a ray box, a white sheet of paper, and a plain mirror. We start our experiment by drawing the position of the mirror and the line which is the normal to the mirror. We switch on the ray box and we immediately note the incident and reflected ray of light. Using a pencil, we mark some dots on the incident and reflected rays, such that when we remove the mirror and switch off the ray box, we can trace these rays. We remove the mirror, switching off the ray box, and with a ruler we can draw now the reflected and incident rays. After the drawings, we will measure the angles using the protractor, so that we will measure the angle of incidence and the angle of reflection. In this case, we find that the angle of incidence is 33 degrees and the angle of reflection is 33 degrees. This is in line with the law of reflection. We repeat the experiment by choosing another arbitrary angle of incidence. We mark some dots on the rays of light, and after removing the mirror and switching off the ray box, we will trace again the new reflected and incident rays. After drawing the incident and reflected rays, we use a protractor and again we measure the two angles. We measure the angles always from the normal to the rays. In this case, we find that the angle of incidence is 54 and the angle of reflection. The second experiment, we require a ray box, a rectangular transparent block, and a white sheet of paper. We start with marking the boundary of the rectangular block on the paper and draw a normal to one of its faces. Switching on the ray box, we will mark with a pencil the rays of light, the incident ray of light and the emergent ray of light. We cannot mark up the refracted ray of light, which is inside the block. We switch off the light and remove the glass block, and with the use of a ruler we can now trace the incident ray of light, the refracted ray of light inside the block, and the emergent ray of light coming out from the opposite face of the block. Using again a protractor, we can measure the angles. We always measure the angles from the normal. The angle of incidence here is 25 degrees. And the angle of refraction inside the glass block is 16. We apply Snell's law, which states that the ratio of the sine of I to the sine of R is a constant. We put in the values and we'll get a result of 1.5. We're going to use the ray box again. Now we change the block and use a semicircular transparent block. And a white sheet of paper, starting with marking the boundary of the semicircular glass block and the line which shows the normal to the straight edge. This shows the incident, refracted and emergent rays. With the use of a pencil, we mark some points on the rays of light, so that when we remove the semicircular glass block, we can trace these rays of light using a ruler. We again use a protractor to measure the angles. In this case we have angle I is 27 degrees and this is inside the block, and angle R is 41 degrees which is outside the block. Using this information we can find out the refractive index of the material as well. Please note that the angles should correspond to which side of the material we are talking about. If we increase the angle of incidence inside the block, the angle of refraction increases as well. In this case, the rays of light are moving from a dense material to a less dense material. On increasing the angle of incidence inside the block, we arrive to a point where the emergent ray skims the surface, and that is called the critical angle. Using a pencil we mark some dots on the two rays of light, such that these points will help us to trace these two rays of light. We remove the semicircular glass block and the light, and using a ruler we can now trace the two rays of light. If we keep on increasing the angle inside the block, we note that total internal reflection occurs. No light escapes into the outside medium. Using a protractor we can now measure the two angles, and we find that the angle of incidence to the straight edge is 56 degrees and the angle of reflection is 54 degrees. So we can say this is in line with the law of reflection.